Hello students, hi. Hello students, hi everyone. Hi everyone. Hello students, hi everyone. Good evening all. Students, I hope you all are good, right? Fine. So, welcome to GTQ session. This session we are going to discuss computer organization lecture subject related. That means expected question, predicted question. Okay, students. All right. Without wasting time, we'll proceed with the question. This is the first question. Consider the following sign magnitude data. Here they given sign magnitude. In which of the case overflow sign magnitude data given? In which of the case overflow occurred? These are the four options, right? Then to the question, the right answer. Sign magnitude. Just voice issue, no audio. Abhishek, audio issue is there. Students, now audio okay? Check. Audio clear. This is the first question. Some of you are state audio issue. Hope that issue is resolved now. This is the question. Consider the following sign magnitude data. In which of the cases overflow is your answer. Abhishek, answer please. Yeah, some of you are given the answer. So let us see the analysis of. So here it is a sign magnitude data. Sign magnitude data, not a signed data. 10-bit range. Bit range is -2 power n minus 1 plus 2 power n minus. This is the range. Okay. Sign magnitude here MSB reserved for the sign and remaining bits indicate magnitude observation and remaining bits sign magnitude format is. Now here they given different options. First 7-bit. What is the range? 7-bit range is minus 7 यहाँ substitute -63 to +60 is the 7-bit range. Okay. So now here please verify. MSB bit is 1, sign is negative. Right? So remaining bits in value, this is equal to, this is 1, 4, 8 become -8 plus this sign negative, then this is 10. Right? This become -20 present in range. Therefore, no overflow. Here no overflow. Coming to the next one. Here 8-bit C. 8-bit range is what? -127 to +127. -127 to +120. Right. Now here values place. Must be positive. Positive sign. Take the values. What is the value? Verify this. Value of this is 60. Okay. 64 plus 30 plus 8 plus 4 plus 2. That is 110. 110. Then this is negative sign. Then 8. Okay. 16 plus 8 plus 1. That is 25. 110 plus 25. This is become 135 is not in the range. Therefore, here overflow present. 135 range में नहीं है. Overflow present. Next one is what? 6-bit CPU. Bit range is -31 to +31. This is the range. Now here data given as what? MSB bit. Okay, 1, 4, 8 is what? +21 into, right, this is plus positive 1 4, 8, 6 plus 21 minus 20 into plus 21. 21 into 21. Yes, 441. This is also overflow. यहाँ भी overflow satisfied. Last option 9-bit CPU. 9-bit sign magnitude range is minus 255 to plus 255. Now verify. MSB 0 positive. Then 1. This is minus 24 plus 0 1 4 8 64 128. So 128 plus 32 plus 2 162. Okay, 162 minus 24 is plus 138. This plus 130 is in the range, therefore no overflow. Right? So in which of the case overflow present? In this question there is B and C. Some of you already given the right answer without my explanation. Some of you already given right answer. Thank you so much. This is the right answer, B and C. Correct? So in the sign magnitude and one's complement concept, there is no direct formula available to indicate the out of range concept. For example, if it is unsigned data, after arithmetic addition, okay, carry flag is set. Condition is there an extra bit out of MSB? That is the condition. When it is a signed data, 2's complement data, there we have a overflow flag. For the overflow flag also we have a condition. What is the condition? There is a carry into the MSB and no carry out of the MSB or vice versa. Or else you can say same sign of data is added, result contain opposite sign, that is the overflow. So for unsigned numbers and signed numbers, directly we have a carry flag and overflow flag conditions to indicate the overflow. Okay, but this is not the unsigned data. This is not the signed data. This is a sign magnitude data. For the sign magnitude data, we don't have a direct formula to decide the overflow. So manually we need to verify. That is the reason after verification we get the answer B and C. I hope everyone got the same answer. Okay, students. Thank you. Right. Now this is the next question. All of you verify the question. Consider the following signed data multiplication. Consider the following signed data multiplication. Okay, this is the multiplicand. Signed data multiplication is the multiplicand given and multiplier given. Number of arithmetic operations required in the multiplication. How many arithmetic operations required in the multiplication? This is a signed multiplication. Signed data. Friends, जल्दी आंसर करना. Signed data. Signed multiplication. Signed multiplication. Both multiplication. Then how many arithmetic operations? Arithmetic मतलब addition, subtraction. Count number of arithmetic operations, count of subtraction. Some of you already given the answer. Thank you all. Thank you, my dear students. So here in this question, what we are going, simply we are taking the multiplier. Multiplication is controlled by the multiplier. Multiplier is 0, 1, 0, 1, 0, 1, 0, 1. This is the given multiplier. Obviously, this, okay, we assume q subscript minus 1 as 0. So this is the assumption. For the initial bit pair, we want one assumption, q subscript minus equal to 0. Now bit pair and the operations. According to the Booth's multiplication, bit pair related actions are 0, 0, 0, 1, 1, 0, 1. When bit pair is 0, 0, only ASR, 0, 1, addition and ASR, and 1, 0, subtraction and ASR, and 1, 1, only ASR, arithmetic shift right. So these are the operations with respect to the bit pairs. Everyone knows that. Then follow the same here. This is the 1, 0, S1. Then 0, 1, S1. 1, 0, minus 1. 0, 1, S1. 1, 0, minus 1. 0, 1, S1. 1, 0, minus 1. 0, 1. Then how many arithmetic operations required? Just count plus and minus operators. 4, 5, 6, 7, 8. So answer is 8 arithmetic operations required in the Booth's multiplication of above data. Okay, all are given right answer. All, every student. 8 is the answer. Thank you all, friends. Okay, fine. Right. Some of you are asking the doubts. Sir, previous question, are we restrict or strict to this method? Yes, obviously you should maintain the same methodology, because sign magnitude practically not implemented, one's complement practically not implemented. So if you want to identify overflow condition in a sign magnitude and one's complement, you should take the given data, converting that into a equivalent decimal, and do the assigned operation and compare with the result range. If result a range में है तो there is no overflow. Result range में नहीं है तो that is a overflow. The method. There is no direct flags available for the sign magnitude format and one's complement format. There is a flag available for the unsigned, that is carry. There is a flag available for the signed data, that is a overflow. Okay na? So sign magnitude के लिए, one's complement के लिए, there is no flags available. Okay, so manually we should verify like this. Okay students, now this is the third question. All of you, please read the question, give the right answer. Students, this is the question. Consider the following multiplication. So here 4 options B, C, D. Multiplicand given, multiplier also given. In which of the above cases, number of arithmetic operations required in the multiplication is greater than 6? Is the question. In which of the above cases, number of arithmetic operations required in the multiplication is greater than 6? Students, nowadays we are expecting this kind of lengthy question. You know, in the previous question, they given only one multiplicand, only one multiplier. Number of arithmetic operations directly we calculate. Okay, but in today's question paper, they given the lengthy questions, not only one multiplicand and multiplier. There are different multiplicands and multipliers mentioned. They are asking the question like so, time consuming, but bit practice required to do the to give the right answer. Thank you, my dear students. Thank you so much. Thank you so much because you all given the right answer in the answer. Means a lot. See, okay, given multiplier 1, 0, 1. This is the Q naught. Now take Q subscript minus 1 initialized with 0, 0, 1, 1, 0, 0, 1, 1. Not assume Q subscript 0. 1, 1, 0, 1 is Q subscript 1, 0, 1, 0, 1, 0, 1, 0. This is Q naught. Q subscript minus. Then verify. Pairing rate. Here, this pair. Next pair. S1. Next pair. Minus 1. Pair. Pair. Next pair. You know, the number of operations. 5. 5 arithmetic. So 1 arithmetic. 1, 0, 1. So minus 1. 1, 0, 1, 1, 1, 2, 6, 7 arithmetic operations required. 1, 0, 1, 1, 0, 0, 1 plus 1, 1, 0, 1, 1, 0, 1, 2, 7, 7, 7 are the what the question in which of the above cases of arithmetic in the is greater than 6. So greater present C and D. This question C and D is DC. D. Very good. Thank you, student. All given right. Right? Verify. Consider the following whose in which of the case occur. The question. Consider the following of the cases overflow. Is the answer. Yeah. Wait up. Aditya, Abhishek, answer क्या? Now listen. Here, we state complement data whose signed data. Overflow flag is sexy. इसलिए manual verification not required. Directly we have overflow use complement directly overflow flag. What is the condition? Condition is like this. Overflow of x comma y comma equal to x y x bar y bar z or x y z bar. The concept. So x is the MSB of first operand, y is the MSB of z is the MSB of a result, called as the positive overflow. This is called as the negative overflow. Directly you do uh, the addition operation and compare with this result. When same sign data is added, result contain opposite sign, that is the overflow. Okay, the meaning same sign data added. result contain opposite sign is an overflow. In sign data added, result contain opposite sign is an overflow. So directly हम use कर सकते in this question, but this kind of method, this kind of condition we cannot use in the first question. First question is a signed magnet, उसके लिए overflow flag is for the signed data. That signed data default 2's complement, 2's complement data a condition sign magnitude 1's complement format के ऐसा flag कंप्यूटर में नहीं है, because those two formats practically not used in the computer. That's what in those cases manually we verify the information, but यहाँ manual verification is not, directly a condition से compare करते. Okay, so now verify this. First same sign data, यहाँ देखो this is opposite sign, तो इसमें ओवरफ्लो कभी भी नहीं आता. Opposite sign data addition never causes overflow. में overflow नहीं आएगा, overflow in the opposite sign. Same sign data में overflow आता है. Now do the addition of this. दोनों numbers add करो. Let me take 0 1 1 0 1 1 0. Now addition 1 1 0. Now verify the condition MSB, MSB, MSB. So this is looking like X, this is looking like Y, this is Z bar. So X, Y, Z bar equal to negative overflow. Here negative overflow present. Now coming to B option, B not there. Now 0 1 0 1 0 1 0 0 1 0 0 1 1 0 1 0 0 1. Now addition 1 1 1 1 0 1. Now if you verify this, like a X bar, Y bar, Z. So X bar, Y bar, Z is equal to positive overflow. Positive overflow present. Then D, option D, 1 1 1 0 1 1 0 1 0 1. Then 1 0 1 1 0, right? 1 1 1 0 0. Adding them 1 0 0 1 0 1 1. Now verify the MSB verify करना. This is 1, this is also 1. Then overflow is equal to 0. Overflow not present. Okay. In which of the cases overflow occurs? Then what is the answer? In A and C, overflow present. The answer is remaining case, no overflow present. Okay, student. Hope you understand. You need to do question here manual कन्वर्शन नॉट रिक्वायर्ड. ओके, रेंज से कंपेयर करने का जरूरत, because whose complement is by default implemented in the computer as a signed data. उसके लिए we have the overflow. तो ये overflow flag condition से कंपेयर किया तो हमको आंसर मिलता है. वॉइस इश्यू. स्केल अप द क्वेश्चंस. इसके लिए बताओ. Consider the following ones complement data addition. These all are important. Ones complement. In which of the cases overflow occurred? Yeah. You may use gate up. XOR operation is also present. There are three ways present to indicate the overflow. XOR operation between in carry and out carry with respect to MSB is also the overflow. That also you. Okay, signed data overflow के लिए three methods are there. One is the plain English. There is a carry into MSB and no carry out of MSB or vice versa. Second is the XOR operation between in carry and out carry with respect to MSB. Third is the when same sign of data is added, result contain opposite sign is the overflow. All right. Now this one is what? One's complement. One's complement. इसके लिए overflow flag. Then how can we use? जल्दी. Yashika Verma. Ishika Verma, you please practice the questions in this level. These are important questions. Ishika Verma, what is the answer to this question? Now this is again one's complement. One's complement data के लिए there is no direct condition present. Unsigned के लिए direct condition is sign magnet. Signed data के लिए direct condition is. One's complement के लिए sign magnitude के लिए direct condition नहीं है. Then क्या करना? We are going to do this manual. So how many bits of data given? 5 bits data. So 5-bit range is one's complement range minus 2 power 5 minus plus 2 power 5 minus 1 minus. So this becomes minus 15 to is the range. Now you please verify. A, what is given? 1 1 0 1 1 1 0 1 0. Then 1 0 1 0 1. Right now MSB bit is 1, n is negative. Then take the complement, one's complement. So 0 0, right, 1 0 1 is equal to minus 5. Then sign is negative. Then take the complement 0 1 0 1 0. This is equal to minus 10. So दोनों addition minus 15. Minus 15 is in the range. No overflow. Now B 0 1 1 0 0 0 0 1 0. MSB bit is 0. Sign is positive. No need of complement. MSB bit is 0. Sign is positive. No need of complement. This is plus 22. Plus 22 is not in the above range. This is the overflow. Next C. What is C? 1 1 0 1 1. 1 1 1 0 0. MSB bit is 1. Sign is negative. Take the complement. Okay. 0 0 1 0 0. This becomes minus 4. MSB bit is 1, sign negative. Take the complement. 0 0 0 1 1 is minus 3. Become minus 7. So Is minus 7 present in the range? No need to take any no overflow. Now D option 1 0 1 0 0 1 1 0 0 1 0. MSB bit is 1, sign is negative. Take complements 0 1 0 1 1. Become minus 30 minus 11. Next, MSB bit is 1, sign is negative. Take complement 0 1 1 0 1 is equal to minus 30. Right? Now addition minus 24. Minus 24 is not in the range, therefore overflow present. So what is the answer? Your correct answer is, in which of the cases overflow occurs? B and C. My dear students, after solving these questions, you may understand the meaning of overflow. Correct? Once complement के लिए overflow verified like this. Sign magnitude के लिए overflow verified like question number 1. Okay, 2's complement that is signed data के लिए directly overflow flag condition से overflow verify करते. Okay, 3 variations I explained. I hope you understand the same. Then right answer B and D. Signed and unsigned के लिए directly conditions available. Okay, sign magnitude and ones complement के लिए direct condition not available. इसीलिए sign magnitude and ones complement के लिए manually we are verifying the overflow condition like this. Yeah, range method works in all. Get up, you are asking, range method is working. This method is working for all, but unnecessarily signed data के लिए ये method follow किया तो time consume होता है ना, इसीलिए यहाँ ऐसा करते. यहाँ देखो 2's complement, यहाँ range method follow किया तो it will take more time. That is the reason directly we use the condition of the overflow because 2's complement. यहाँ one's complement के लिए ऐसा condition नहीं है, so compulsory we should take the range concept. Okay, all right. Yashika, is your answer matched? Coming to next question. Consider the following format. The format 1 bit, 7 bit, 8 bit, 5s. What is the final product in hexadecimal after perform the multiplication of the given memory data? These are the numbers. Multiplication given, multiplier given. They ask about the final product. That too in the hexadecimal. Is Abhishek. Yes, yes. Yes, correct. Some students are not giving any answer. Still, they want some high level of the question. High level nahi hai. These are the high level questions. You know the difference between different questions. Same question is not repeated. Compulsory variation is when you practice questions in this level, compulsory you are in a position to answer the gate questions also. All are good. Is है ना, कुछ तो कुछ डिफरेंस आपको पता चलेगा क्वेश्चन टू क्वेश्चन. So apart from our class notes, apart from class notes questions, these are some additional. When you practice questions in this order, okay, you are in a position to answer coming gate Please give the answer. This is the question. How can we answer? So, करो the solution. Friends, what is the answer? Friends, this is the actually procedure everyone knows. First to take two numbers, x, add the exponent. Okay, normally if your data is having the actual exponents, after adding two actual exponents, we have still actual exponent, add the bias. Okay, for example, ऐसा है 1.101 into 2 to the power of plus 5, 1.1101 into 2 to the power of minus 5. ऐसा these two are the actual exponents. Actual exponents add किया तो there is no double bias. Okay, biased exponents add किया तो compulsory two biased exponents are added, result contain the double bias. Multiplication. This is the procedure. Then do the question. This is the answer. Try the step. Two numbers is given FB E0 base H. Then Y is given BC80 base H. Now you know that X value 111 10 00 5 3 00 C 1100 8 1000. So these are the two numbers. Now interpret this into a format. What is the format? MSB is the sign. Very good. Then 7 bits 1 2 3 4 5 7. This is the B, and remaining are the mantis. Remaining are the mantis. Okay. So here what we need to do? Simply we are taking the sign. Sign is positive and negative sign. Compulsory positive and negative sign multiply किया तो sign will be the negative. Then Second step is what? Add the exponent. So here, first exponent x what already be in a 1 1 1 1 0 1 1. Next BE. First operand BE, second operand BE. 0 1 1 1 1 0. दोनों directly add करो. Oh. So now this is the double biased export. Okay. Therefore, subtract the bias. What is the bias? Bias of this format is excess bias. Excess bias is 1 0 0 0 0 0 0. So subtract करो. Okay. Subtract the bias. So 0 minus 1 1. 1 minus 0 1. 1 minus 0 1. 1 minus 0 1. 0 minus 0 1 minus 1. 1 minus 0 1. 1 minus 0 1. 0 minus 1 not possible. Now we want borrow. After taking the borrow, okay, this become 2 base. 2 minus 1 1. Now this is the B. This is the B. Dear student. Okay. Next. Third step is what? Multiply the mantissa. So 1 point x mantissa is normalized mantissa 1.1100 and so. Then y mantissa is 1.1000. So इसका value कितना है? X value 1.11. 1.1 is nothing but 1.75. So this is 1.5. So 1.75 multiplied with 1.5. Then what is the answer? The option is correct. Yashika given. .625. 210.625 101. Okay, right. So now we should take the fourth step. Normalize the result. Minus 10.101 2 power 111.011. Right. So normalization. Align to right, comma 1 time. Only one time right alignment karo. Yes, 1.01 into 2 to the power of 1 1. Okay, 1 0 1 1 1 plus 1. So minus 1.0101 2 power 1111000. Then store it into a memory. Already this is BE, right? Now storage is storage. Line is negative. BE 1111.000. It okay? Then mantissa 0101 and the remaining all are. Now group the 4 bits. 4 bits, 4 bits, 4 bits. F 8 5 5 0 is the 50. Which one is my? Okay, students, this is the procedure. Okay, some of you are solving like this. Some of you are solving like this. X is given like this. Then इसका value decimal में convert करके, again y value decimal में convert करके, वो दोनों decimal numbers multiply करके, again you are doing the same procedure. So instead of doing that, a direct approach. Okay, students. Okay, Yashika, thank you so much. You are in IIT Kharagpur. Oh, great. Last year student. Good. Yeah. This rule is applicable all IEEE. Yeah, correct. This is the standard method. Okay. For example, if I given the question like this, question equal to minus 2.75 into 2 to the power of plus 6 y plus 3.25 into 2 to the power of plus 8. If I given like this, these are the actual exponents. ये दोनों actual exponents add करके at the time of storing bias we are adding, but this is already memory data. Memory data is already biased exponent data. Because of this is already biased exponent, two biased exponents are added, result is in the double bias format. इसलिए एक bias subtract किया तो we get the actual biased exponent. Okay, biased exponent दोनों add, then we get the double bias. Then after subtracting the bias, we get the single biased exponent. That is the concept. Okay student, तो इसके लिए ये मेथड अप्लीकेबल नहीं है, तो +6 ऐड करो +8 से, आफ्टर दैट ऐड द बायस, देन स्टोर द रिजल्ट. तो क्वेश्चन अकॉर्डिंग टू द क्वेश्चन वी शुड टेक द एक्शन. Okay students, thank you so much. Yashika, you given right answer. See, setup you are saying, I don't know this kind of, now I know. Correct? When you are solving the question, you came to know some strange points also. Okay students, question clear? Who given right answer? Yashika Verma. Also. Yashika, please wait for other complicated. So number system में इतना complicated scenarios. No, this is the question. Consider the following binary with respect to the floating memory data. Which of the following, here 6 numbers given, memory contents given, which of the following represents n, कहाँ represent हो? Question also will do. Don't worry. Pipeline question also. NaN के लिए binary code line is equal to 0. This is NaN. Okay, given options आप check करो. First one, yeah, again 4 ones, then 5, 0 1, then 2 1, 8 1 0 0 0. Now 3 7 0 1 1 F 1 1 1 1 9 1 0 0 1 2 0 0 1 fourth one 7 0 1 1 F 1 1 1 8 1 0 0 0 0 0 5 F F 7 6 and 6 7 4 4 1 0. All right. So now divide करना sign. Then next 8 bits. Correct. Now यहाँ दे M. This is not a NaN but a special value minus infinity. Special value minus infinity. Then this is what is NaN. Next, this is what special value plus infinity. Infinity. Okay. Then what about this? This is not a NaN. This is the normalized number. Quantities are the representable normalized numbers. Normalized representable data, not a subnormal data. Subnormal. Representable normalized number. Then what the question? यहाँ NaN कहाँ है? Only for and third one. Then A, B, C, D options. Then where the NaN present? NaN present 1 and 3. So answer is B. B is the right answer. Very good. Ratnesh Pandey, right answer. B option. Thank you, GitHub. Yashika, your answer matched. The question is diagram. Consider the following hardware design. X0, X. Okay, decoder circuit. D0, D2. They are connected to memory chips. How much memory space is addressed by the status of X1, X0 as 0, 0 and 1, 1 respectively in GB. We want the memory space in GB. How much memory space is possible? Get up Get up already. Yashika place. Yashika is in IIT Kharagpur. Last year student. Made is the last year regular. Already in IIT Kharagpur. Not visible. Oh, here this is D0, D1, D3. These are the A0 to A27. This is D0 to D63. Now here A0 A33. Then D0 to D50. Ratnesh Pandey. Verify. This is A0 to A23. Then this is D0 to D31. Okay. Now this is A0 to A35. And D0 pins or data pins are not. Now यहाँ D0 इसके साथ connected, D1 इसके साथ connected, D इसके साथ connected, D3 इसके. So how much memory space is addressed by the state of x0, x1, 0, 0, 1, 1 respectively. X0, x1 status they given. यहाँ दे. This is x0, this is x1. X0 status is 0, x1 status is. How much memory possible? X0, x1. X0 status is 1, x1 status also 1. Then how much memory possible? Verify. By given, no? These are the decoders. Now you please verify. This is x0. This is x1. Two inputs to the decoder. Now यहाँ 4 outputs present. This is D0, D1, right? D3. Decoder specialty आपको पता है. According to the decoder input status, decoder output signals are this. What is answer? Ratnesh Pandey. Very good. Very nice. Thank you. What is the answer? You tell me. Decoder circuit. पता है ना? Decoder given. When decoder is having two lines, x0 and x1, according to status, you know that 2 by 4 decoder, 4 signals coming, x0, x1, ऐसा x0, x1. When these two are 0, 0, decoder से D0 signal coming out, 0, 1. Then decoder से D1 signal coming out, 1, 0. Decoder से D2 signal coming out, 1, 1. Decoder से D3 signal will be coming out like this. According to the decoder input status, decoder output signals are present. So D0, X0, X1. So accordingly, these are the signals. Now you tell X0, 0, 0. When 0, 0, X1 is 0, decoder output is what? Decoder output signal is D0. Okay. Now D0 activates the memory chip which contain total 36 address pins. को एक्टिवेट करते D0 ये मेमोरी चिप को एक्टिवेट करते 36 एड्रेस पिन्स and data pins not given. Therefore, default cell size is 8-bit. That's it. Default cell size is 8-bit. So, memory capacity is equal to number of cells into cell size. Number of cells 2 to the power of 36 cells into 8-bit. Okay. So, this is equal to 2 power 36 bytes. This becomes 64 GB. Similarly, here, this is 1, 1. When it is 1, 1, decoder output signal is D3. Okay. So, D3 signal may activate memory chip which contain how many? Yeah, D3 is 28 address pins. 28 address pins and 64 data pins. Cell size given 60. Therefore, what is the memory size? Memory size is equal to 2 to the power of 28 cells. In each cell, 64 bits. So this becomes 2 power 28. 64 bit is nothing but 8 bytes. So this is 2 power 31 bytes. Become 2 GB. Is it okay, student? Right. Then what the question is expecting? How much memory space expressed by the status of x0, x1 as 0, 0 and 1, 1 respectively. When 0, 0 is there, how much memory is possible? GB 64. And 1, 1 is there, then 2 GB. Then answer is 64 and 2. 64 GB and 2 GB with respect to the given state. Okay, student. When question does not contain the memory cell size, default memory cell size is always 8-bit. Default memory cell size is 8-bit by default assumption. Okay, इसलिए यहाँ data pins not given. That's what we taken. Default cell size is 8. And remaining cases में data size given, so that cell size varies. When cell size not mentioned, default cell size is 8. Okay, student. हाँ 36 एड्रेस पिन्स विजिबल नहीं है, मैंने यहाँ लिख दिया ना. Students, I know diagram is very small, pins not visible. That's what I given like this. A0 to A35, A0, A0, A23, A0 to A20, D0 to D30. मैंने ऐसा लिख दिया because of this point is very small. That's what that is not properly visible. So I written clearly, उसका accordingly आप आंसर करना. Okay students. Shika, all other students here. I mix the questions. Questions are not coming in a order. Okay, I'll make questions. So please jaldi answer. Consider the following is the multiplicand. Final product in decimal. Final product चाहिए. Please. Aksham Bhatt. You tell what is the answer. Please give. Here, this is the multiplication. Whenever multiplier is there, plus 1 minus, that is the recoding. Solution क्या है? Recoding multiplier or else recoded multiplier. Decoded multiplier. Decoded multiplier. Roots multiplier. Here multiplicand already there. What is the multiplicand? Multiplicand is 1 0 1 1 1 1. MSB bit is 1, sign is negative. Then take the 2's common. So 1 1 0 0, add 1. So 1 0 1 0. Now this is 1 2 8 16 32. So this becomes 37. 1 2 4 8 30 plus 4 36 plus 1 37. This is minus 37. Multiplicand is minus 37. Then multiplier we want. Multiplier. Decoded multiplier given. Bit pair please. Bit pair. Then decoded multiplier. Already mentioned. So what is the recoded multiplier? So LSB. Is LSB say. LSB to 0 1 plus 1 minus 1 0 plus 1 minus. Now pair, first pair, Q naught, Q subscript minus. Okay, Q subscript minus 1 by default assumed as. Now bolo, when it is a recoded multiplier is 0, bit pair should be either 0 or 0 0 or 1 0. So already one bit is 0, then opposite bit should be 0. Now take this bit diagonally here. Then this is minus 1. Minus 1 is 1. 1 is diagonally here. You tell. This is plus 1. Pair is 0 1. 0 diagonally here. This is minus 1. So pair is 1 0. 1 diagonally same. Dekho. This is 0. Bit pair either 0 0 or 1 1. Value should be 0. So here one bit is already 1. For another bit also 1. Pair should be 1 1. So 1 diagonally taken plus 1 is 0 1. 0 diagonally taken, okay, that is -1, it is 1 0. Okay, this is the bit pair. Hope you understand this. You know this already. The q naught position, this is the q subscript -1, assuming like this. Then binary multiplier is this. This is the binary multiplier. So now take binary multiplier, that is what? 1 0 1 0 1 0. This is the binary multiplier. The binary multiplier. Okay. Now MSB bit is what? 1. Sign is negative. When sign is negative, take 2's complement. 0 1 0 0 1 1. Add 1 1 1 0 0 1 0. Then 1 2 4 8 16 32. So this become what? 36 plus 2 38. Now bring it here, that is -38. Then final product is in the decimal, so product equal to -37 into -38. Minus minus positive plus 37 into 38, 1406. This is the answer. Okay students, hope you understand. 1406, correct. Ratnesh, even right answer. Sakshyam, what is the answer? Plus 140. Ishika Verma, is verified. Here multiplicand is already given. 1 0 1 1 1 1. Signed data. MSB bit. Why I taken signed data? Because recoded multiplier given. Recoded multiplier there in the Booth's multiplication. Booth's multiplication is by default used for the signed numbers. That's what we take in the signed data. Booth's complement. MSB bit is 1, sign is negative. Okay, Booth's complement. Okay, used for the signed multiplication. Mainly used for signed multiplication. Designed for signed multiplication. That's what data sign is a signed data. Default 2's complement. MSB bit is sign is negative. Take the 2's complement के बाद value -30. Now recoded bit pairs. Recoded multiplier is given, bit pairs we are taking. According to the pair, we know the binary multiplier. This is binary multiplier. MSB bit is 1. Take 2's complement. Value -30. दोनों multiply किया. Answer is plus 14. Okay. Okay students, any doubts? Any queries? Previous questions, when I solve the previous question somewhere, friends, you know this process. Previous questions देखो. This is the binary multiplier. Binary multiplier given, you know how to convert binary multiplier into recoded multiplier. ये है recoded multiplier conversion पता है. Now क्या है? Recoded multiplier given, उससे हम binary multiplier को find out किया. That is the Okay, all right. Now, students, this is a good one important question. Jaldi, jaldi. Consider the following hypothetical form. This is the data present in memory. This is the data ABCD. Four data. Which of the following are correct? So, in the last year, in last year GTQ, I explained this kind of a question. Exactly, I saw question मैंने GTQ में explain किया ना. So fortunately in the last year gate paper ऐसा ही question directly present in the. Okay, so nowadays complicated questions, lengthy questions are formulated in the paper. Okay, that is the reason you please be ready to practice questions quickly. Okay, all right, this is the thing. We see again how many of you are giving the right answer. Jaldi jaldi answer karna so that we can solve more questions. Please do it quickly. रत्नेश पांडे सॉफ्टवेयर इंजीनियर जल्दी करना है. So to solve this question, first what you need to do, you need to convert the data into a decimal, because यहाँ options में सारा decimals हैं. तो decimal. So this is the memory data. Convert this memory data into decimal first, and after that substitute this. You may get the answer. Okay. So here, what is the bias? Bias equal to default normal bias. Normal bias, that is plus 2 power n minus 1 minus. That is plus 2 power plus 31. The bias. Then value formula is what? Decimal value के लिए minus 1 to the power of x 1.m into 2 to the power of BE minus bias is the formula used. Minus bias. Okay, student, formula use कर. Right. Now substitute A 0 1 0 0 1 0 0 1 0 1 0 1. Now divide this 1 bit 6 bits 5 bits. S E M. The value पता करो. Value is equal to minus 1 to the power of 0 1.10 to the power of E. What is the BE value here? Is 1 2 4 8 16 32. 32 plus 4 36, right? 36 minus 30. This is plus 1.10101 2 to the power of 5. So when you want a decimal, make this exponent 0. So plus 1 into 2 power 5 minus 5 cancel. So इसका value पता करो 1 4 8 16 32. Is it okay? Now 32 plus 16 plus 4 plus 1, that is 53. So this is equal to plus 53. Right? Now, similarly, do the remaining quickly. For B, what is that? 1 0 1 1 1 0 1 0 1 0 0 0. Sign is negative. Value. Same thing. Minus 1 to the power of 1, 1.01000 into 2 to the power of, okay, what is this value? 29, correct? 29 minus 31. So minus 1.01 into 2 to the power of minus. Okay, so minus 0.01010000 into 2 power minus 2 plus 2. Now इसका value find out. Minus 2 minus 1 minus 3. So this is 1 upon 4.25, 1 upon 16. Now this is minus 0.3125. Similarly, E value and D value पता कर लो. E value 1 1 0 0 0 1 1 0. Value minus 1 to the power of 1, 1.01101 into 2 to the power of, what is this? 32 minus 32, yeah, 34 minus 30. So minus 1.01101 into 2 power 3. Now minus 1011.01 into 2 power 3 minus. So now इसका value कितना? Minus, okay, 11.25. Right. Now similarly, D value. Find D value. Is D. D value is 0 0 1 1 1 1 0. Then now what is the value? Value is minus 1 to the power of 0, 1.1 into 2 to the power of 30 minus 31. So my plus 1.101 into 2 power minus 1. Okay, plus 0.11010 to power minus 1 plus 1. Now values please. So this is 1 upon 16, that is 0.065 plus 0.25 plus 0.5 is plus 0.8125. Is it okay? Now compare with it. Report which is matched. A plus B plus 53 plus minus 0.3125, okay, minus 7.5, okay, plus 0.8125. This is what? 42.25. Okay, now is it matching? Greater than? No, is false. Then 4A minus 4B minus C plus 8 into D greater than 68.875. B 53 minus 4 into, okay, minus 0.3125, okay, minus, right, C minus 11.25, okay, plus 8 into 0.8125. What is this? Is it greater than 68.875? Check it. 4 into 0.3125. 1.25. 7.5. 8 into 0.812. 0.5 plus 11 plus 1.50 is 72 point. Okay, student. Now is it greater than? Then b square plus c square plus a plus d is less than 170.25 a square. Obviously b square matlab 0.3125. Option b square 0.0976 plus c square 11.25. 126.56 plus a c3 plus d 812. Add it. 53 plus 0.8125 plus 0.0976. This is 180.47. Now you tell, is it less than 170.25? No, it's a greater than, no? Or this option is also not. Then a into b plus c into d is equal to minus 25.703 up to 3 decimal places. Decision 3 decimal places tak hai. Right? Now d option here, a into b minus 53 into minus 0.3125 minus 16.5625. Yes. Okay. 11.25 into 0.8125. This is minus 9.140. Result minus minus 25.703125. So only 3 decimal places. So minus 25.70. Now what is the answer? Exactly, it is also matched. In this question, correct answer is B and D. ऐसा solve कर. It's a lengthy question. Even though the exam they may formulate this question as a marks weight. Already last year paper में yeah, lengthy question. Actually, in the GATE paper, okay, when examiner formulated lengthy question in one subject, okay, obviously in another subject easy questions are formulated because examiner को पता है timing and weightage and complexity of the paper. So that's what, you don't worry. In every subject you need to prepare questions like this. We don't know in which subject they prepare the lengthy questions, in which subject the easy. Cannot predict. That's what be ready. Okay, students. Very good. is the question. Healthy. Question pado. Consider 16-bit C which support one word opcode. 64 register, each register being 16-bit wide and 128 MB memory. System supports following instruction format. In a format, opcode register memory, opcode memory 13-bit. 13-bit immediate. This value is 13. Then maximum signed positive constant plus 1023. Maximum sign magnitude positive constant plus 11 plus 511. What is the size of 2a plus 4b plus bc in bits? Give the answer quick. Three formats a register in memory. Find out the length of b opcode memory 13-bit immediate. Please students जल्दी कर. Then see opcode register. Okay, maximum signed constant, signed positive constant plus 1023. Maximum sign magnitude constant positive constant plus 511. Then report. Nish Pandey. Okay, right. Students, यहाँ check करो. It is a 16-bit CPU. They given. Therefore, word length is equal to 16-bit. Very nice. Then opcode size is equal to question में given one word. One word opcode is nothing but a 16-bit opcode. Then here register file size is equal to 64 register. So each register being 16-bit wide. इसका meaning ऐसा है. There are the R0, R1 and on R63. So in every register 16-bit space is there. That is its. Therefore, register address is equal to log 64 base 2. That is a 6. Okay, इसके बाद memory size. Memory size is equal to how much? 128 MB. Therefore, address is equal to log 128 mega cells base 2 is equal to 27-bit address. Then substitute that information here. Report the value. So opcode size is 60. Register address is 6. Again 6 bit. Then memory is 27. That is the A value. Next opcode is 16 bit. Memory is 27 bit. Then 13 bit space already given. That is the B. C. Opcode is 16 bit. Register is 6 bit. Okay, maximum signed constant. Signed constant is this. What is this? 2's complement range. 2's complement range minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. So here 11 bit if you have, then plus 1023 is the constant. Then this is sign magnitude. Sign magnitude. Okay, what is the range? Minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1. Okay, plus 11 if you want, then 10 bit space check. When it is a 10 bit space, then it become plus 511. When it is 11 bit space, then it become plus 1023. Okay, ये लॉजिक पता है तो then आप आंसर कर सकते. तो 16 plus 6 plus 6 plus 27. This is 55 bit. Then 16 plus 27 plus 13. This is 50. Then here 16 plus 6 plus 11 plus 10 is equal to 43. What is the value of what they given? Value of 2a plus 4b plus 3c plus 4 into 50 plus 3 into 40. Total 2 into 55, 4 into 56 plus 3 into 40. Answer is thank you. Thank you. Your answers. So practice like this, okay? One question we accommodated multiple things. Easy to solve. The answer matched or not. Now verify this question. Consider 16-bit CPU, very good 16-bit CPU which supports 20-bit opcode, 100 register, 4 GB RAM. Instruction is designed with address format. Address 1 uses register indirect mode. Address 2 uses memory indirect mode. Opcode designed for addition opcode, where address 1 acts as a and also destination. Address 2 acting as memory reference by user. ALU consume register reference consume 0. So number of cycles required to related in mode along with format. Please read the question, solve it, do it quick. But mind one thing, whenever memory indirect addressing mode is there, in our regular class, I ask you to open your eyes a little big. For what purpose? To check the address size. Because memory indirect addressing mode may effective address is in the memory. So memory say effective address access karna. Address size is important. Okay, if address is one word, then one MR is required. If address size is two word, two MR required to get the effective address. Address size is four word, then four MR required to get the effective address. So be careful when indirect addressing mode is present. Format. Please, jaldi. Please check it. Students answer kya? Now voice okay? The question what they there is a 16-bit CPU is a 16. Therefore, word length is equal to 6. But there is an instruction to address for to address instruction. The output is one. There is address 2. Address 1 using the register indirect addressing. Address 2 using the memory indirect addressing. So when it is a register indirect addressing mode, this address field contains address of effective address. is register name, register address. Okay. Now यहाँ the meaning क्या? When it is a memory indirect, this address will contain address of effective address. That is memory address. यहाँ memory address is very good. So now opcode size. Opcode size is 20 bit already given. Registers. How many registers? 100. Log 100 base 2 is 7 bit. Memory address. Log 4 gigacells base 2, that is 32 bit. Therefore, instruction size equal to 20 plus 7 plus 32 bits. Okay. 20 plus 7 plus 32. This is equal to 59 bits. Approximately how many bytes? Okay, 59. This is 8 bytes approximately. Okay, so 8 bytes approximately means approximately this is equal to 4 words. 4 words. Because of word size is 16, 2 byte. 2 byte is 1 word. Okay. Now, here address size, memory capacity kitna? Memory is equal to 4 GB. Therefore, address is equal to log 4 gigacells base 2. That is 32 bit address. 32 bit matlab 2 words. Address size is 2 words. Okay, students. Now you please do the further calculation. When you want to execute this instruction, what is required? All instruction fetch, instruction decode, operand fetch, process data, write back, source 1, source 2, destination. This is the instruction cycle framework. Right? Okay. Now first fetch and decode, instruction fetch and decode. Total instruction is coming. Kitna word? Approximately 4 words. 4 words instruct. Therefore 4 MR. Actually IF में opcode fetch, ID में remaining part of instruction fetch. Already हमको पता है it is a 4 word instruction, so that 4 memory references required. After that, source 1 is a register indirect. Therefore 1 RR. Okay. Later 1 MR. So this RR is the effective address. In place of 1 RR, you take 2 RR. Why 2 RR? Address is equal to 2 words. 2 words address present in the 2 registers. 2 RR. Next one, please. Here, memory indirect addressing mode. Here, 2 MR, because address size is 2 words. So to get the 2 words address, 2 MR. After that, 1 MR per data. Next, 1 ALU operation, addition operation, 1 ALU. Then destination, register indirect, same story. Address equal to 2 words. Address equal to 2 words. Therefore, 2 RR, register reference. Later 1 MR for writing purpose. So register references 0 cycles. ALU how many? 5 cycles. ALU 3 cycles. Memory 5 cycles. They given 4 plus 1 5. 5 plus 3 8. 8 plus 1 9. 9 MR into 5 cycles plus 1 ALU into 3 cycles. 3 cycles plus, okay, RR. How many register references? 2, 2, 4 R, 4 register references according to this into 0 cycle. Okay, so 45 plus 3 is 48 cycles. Okay, students, like this we may solve the question. Addressing modes related question. "48 cycles" is the answer. Ratnesh Pandey, you are saying if question is 8-bit CPU, even it is a 8-bit CPU, instruction fetch 8 bytes, मतलब 8 words चाहिए. When it is 8-bit CPU, 8 bytes storage, so that 8 words. Then 32-bit means 4 words. So according to word length, it is automatically changing. Okay, students, is this question clear? Next question. Now, get up, you are asking expand opcode question. Is that question? Consider 32-bit CPU which supports 24-bit instruction placed in 16 KB memory. Register file size is 32. Each register with a wide of 32 bits. If there exists 30 to address register instructions, 8 to address register and 7-bit immediate constant, 1020 one address memory instruction, number of 0 address instructions present in the system. Jaldi solve the question. Quick. Solve the question. I am just writing. Explain. According to question, this is the matter. There are the different instruction format to address register, opcode, register. To address register and immediate, opcode, register and immediate. One address, memory, so opcode, memory address, and 0 address, only opcode. This is the matter given in the question. So here 32-bit CPU mentioned. Therefore, word length is equal to 32-bit. Instruction size equal to 24-bit. So in this question, this word size is extra information. This extra information we don't want in the solution. 24-bit formats, different formats they given. Okay, all different formats are having the same size, fixed length. Therefore, expand opcode technique use करना. Use expand opcode to address register instruction, to address register in immediate one address memory, 0 address. Let me see how many of you giving the students answer. Is a 24-bit instruction. All the instructions same 24-bit 24. So register, how many? 32 registers are there. 32 registers. This is a 5-bit. Then 5-bit register, 7-bit immediate. Now 12-bit. Next, memory address 16 KB, 14-bit, then 10-bit opcode. Then this is 24. Now small opcode is a primitive. Next small, this is derived. Next small 14 is further derived. Small 24 further we take like this. Now हम क्या करना? Primitive to derived, number of bits merged. Take the difference between 12 minus 10, that is 2 bits merge करना. Then derived to further derived. How many bits are merged? Take the difference between opcode. Again 2 bits merge. Then further derived to further derived. ये दोनों का बीच में how many bits are merging? Number of bits merging. 24 minus 14 equal to 10 bits. This is the expand opcode technique. Everyone knows this. Expand opcode. Okay, now start. Ratnesh Pandey. Yes, right answer. Okay, Ratnesh is correct. Remaining students. First primitive. Equal to 10 bits. So one address is possible equal to possible 2 power 10. 2 power 10. is 102. Third one, number of free opcodes after one address instruction is 1024 minus 1020. Dot 4. Next, number of two address register and immediate instructions possible. 4 into 2 power 2. Then number of pre-op code after two address register and immediate. 16 minus 8. This is equal to 8. Then sixth one, number of two address register instructions possible. That is 8 into 2 power 2. Okay, equal to 30. How many are already existed? 30. Therefore, three opcodes. Three opcodes. After two address register reference, 32 minus 30. That become 2. Now use this pre-op codes for the zero address. Then number of zero address is possible. Zero address instructions possible. 2 into 2 power 10 is equal to 2048. So in this question, answer is 2048. Okay, students. Ratnesh, your answer is correct. Two address instructions दो बार आया. Yes, obviously, because यहाँ two address instruction, this is two address register reference, this is two address register and immediate. ये दोनों अलग अलग फॉर्मेट. टू एड्रेस ही है बट उसका एड्रेसिंग मोड्स आर अलग है, इसलिए इसी सेपरेट फॉर्म का लेंथ अलग है, इसी सेपरेट फॉर्म इसका फील्ड साइजेस अकॉर्डिंग टू द एड्रेसिंग सेटअप. These are the different instructions, different opcode size. Okay, 10 bit to 12 bit increase करो, 12 bit to 14 bit increase करो, 14 bit to 24 bit तक increase करो. तो 10 to 12 bit increase के लिए 2 bit merging करना. ओके, 12 to 14 bit increase करने के लिए 2 bit merge करना. 14 to 24 bit increase करने के लिए 10 bits merge करना. Students, clear? Expand opcode question. Very good. Then see this question. Consider 5-stage pipe with a respective delays of 20 nano, 10 nano. Okay, 5-stage. Interface register used between the stage have a delay of program contain 140 instructions. Speed up factor over non-pipe to run the same program. Very good. Students, you already given the right answers. Yes. यहाँ pipeline given non-uniform delay pipeline. Check this. Pipeline में a value is equal to 5. Total 5 stages. Cycle time is equal to maximum of stage delay plus buffer delay. This is the stage delay plus buffer delay clock adjustment. Right? Now cycle time 20 plus 3. 23, 23 comma 13 comma 23 comma 13 comma 30, because there is no buffer at the end of last स्टेज में बफर नहीं है, देयरफॉर बफर डिले ऐड करने के लिए इसको जरूरत नहीं है. क्वेश्चन में बोला इंटरफेस रजिस्टर यूज्ड बिटवीन द स्टेजेस हैव ए डिले 3 नैनोसेकंड. ओके, एंड ऑफ द स्टेज में बफर है तो 3 लास्ट स्टेज को भी ऐड करना, बट देयर इज ए बफर बिटवीन द स्टेजेस, so no need to add buffer delay at the end of last stage. So this is equal to 30 nanoseconds. N is equal to 140, finite number. Therefore execution time of the pipe is k plus n minus 1 into TP. So k value 5, n value 140 minus 1 into TP 30 nanoseconds. Then calculate the value. Okay, 5 plus 140 minus 1 into 30, 4320 nanoseconds. Okay, यहाँ student mistake is, normally student mistake is students are adding 3 nanoseconds to last stage also. Okay, because formula saying stage delay plus buffer delay, no, buffer delay adding to 30, that is a student mistake. ऐसा नहीं करना. Okay student, all right. Now non pipeline. नॉन पाइपलाइन के लिए ओके, n is equal to obviously 140. Tn is equal to summation of stage delays. No need of the buffer delay. पाइपलाइन में बफर है, नॉन पाइपलाइन में बफर नहीं. तो 20 plus 10 plus 20 plus 10 plus 30 summation of the buffer delay. Okay, so this is equal to 20 nanoseconds. Right, now execution time equal to n into n, 140 into 9, 140 into 90, 12600 nano. Okay student, therefore speed up S is equal to non pipeline execution time divided by pipeline execution. This is 2.91 up to 2 decimal places. 3 decimal places, if they are asking 2.916, depends on the question. 2 decimal places, 3 decimal places. Students, all right. Next question. Verify. An instruction pipeline contains 5 stages: fetching, decoding, execution, write back. But see this, operand fetch, execution, both are placed in the XO. Operand fetch execution stage में होता है. ठीक है, these are the 5 instructions. Y3. Each instruction spending one cycle on each, but load takes 3 cycles on fourth stage. Mull and div takes multiplication and division takes cycles on third stage. Number of cycles is to execute the code with operand forwarding over without operand forward. The question with operand forwarding, without operand. Okay, so IF ID X MA W. So I1 I2 I5 5 instance. So each stage one cycle pending. Okay. Then div and mull taking two cycles. I3 I4 taking 2 cycles on third stage. Load pending 3 cycles on fourth stage. Remaining all are 1. This is the matter according to question. Now dependencies verify karna. See this. I2 I1 no dependency. I3 may dependency is there. I3 dependent on I2, true dependency. Normal dependency dependent on I1 also. I4 dependent on I3. Then I5 dependent on I4. Dependency detected. Then operand forwarding without operand. Operand forwarding. Execute. In this question, verify the things. Operand fetch is in the execution cycle, execution state. Mind this. Operand fetch is in execution state. Okay, so wherever operands are required, वहाँ हम forward करना. So this is the manual procedure. Always manual method gives the accuracy without any mistake. You can do. So with operand forwarding, without operand forwarding, how we can run the program? Verify. So first IF, then I X IF. यहाँ Thomas law algorithm, no dependence. Then M 3 is IF. Okay, now Thomas law algorithm dependent on I2, also on I1. But I1 pending 3 cycles. Up to that, it is waiting on EX, it is waiting on ID, this is waiting on IF. And after that, W, stage is ready. Now MA, now EX, then this is ID, then this is IF. Now in this EX, it is fetching the first operand, accessing the first operand, waiting for the second operand. सेकेंड ऑपरेंड हमको कहाँ मिला, MA के बाद मिला, तो यहाँ से यहाँ तक फॉरवर्ड करना. Then this is still waiting on EX for the second operand. This is waiting on ID. This is waiting on IF. When second operand is ready, then it is proceeding to execution 2 cycles. Okay, now this is still waiting on ID. This is still waiting on IF. The point. Now Thomas law algorithm dependency detected. Now here to here forwarding, EX to EX, operand fetch, forwarding. Now here MA, now EX and ID. Thomas law algorithm dependency detected. But this is taking 2 cycles. Up to that, this is waiting on ID. After that, data forwarding. Now MA, okay, WB, MA, WB. Like this, 16 cycles needed. This is operand forwarding technique. Operand fetch takes place in the EX stage. But यहाँ operand fetch ID में, operand fetch EX में, no problem in this. But without operand forwarding में, there is a problem. How without operand forwarding में problem is there? We will see. Verify. This is IF, then ID, IF, EX, ID, IF. ID में dependency detected, no dependency. So MA, X, ID, IF. Okay, so now MA taking the 3 cycles. That's what it is waiting on EX, waiting on EX, waiting on ID, waiting on IF. Then after that, it is moving on to WB. This is coming on MA. This is EX, this is ID, and this is the IF. Now, what is required? First complete MA. MA complete करने के बाद immediately you can access data, right? Operand fetching takes place in EX. Immediately EX started here. ये देखना. Immediately EX started here because operand fetch takes place in EX. So already it is in the EX for the first operand. Now second operand यहाँ से access करते. Got the point? Now this is coming into where? Still waiting on ID, D, D. This is on IF, F, IF and also IF. So here it will take the 2 cycles only, X and EX. Then this is waiting on ID, this is waiting on IF. Correct? Now Thomas algorithm, it says dependency detected. So इसको complete करो. Complete करने के बाद execution चलाओ. तुरंत. Operand fetch takes place in EX. That's what WB के बाद immediately EX started. EX started. Okay. So now here you can say it is still in EX because first operand fetch करके second operand के लिए waiting करते. Got the point? Now this is in ID, this is in ID. Again ID. All right. So after EX, it is moving into MA. Correct? Now this is coming into EX. Then it is moving on to WB. WB के बाद operand fetch तुरंत. Okay. So now EX, right? Operand fetch MA, right? W. Then how many cycles? 20 cycles. Check it. Here 2, WB के बाद 2. Here WB के बाद 2 ना, not 1. After WB, this is taking 2 cycles, right? X takes. After that, waiting. Then this is MA. This is the WB. After that EX, because operand fetch takes place here. Okay, right. Next MA, only 1 cycle is sufficient. Then WB. Total 21 cycles. Number of cycles saved equal to 21 minus. Okay, students, in our regular notes, I already explained this question also. Okay, many times we are taking operand fetch in the ID stage only. इसीलिए WB के बाद यहाँ देखो WB के बाद in your regular notes one more ID is coming. इसके बाद execution शुरू होता regular notes में. Okay, but यहाँ question में दिया operand fetch is in the execution state, so that WB के बाद operand fetch करके तुरंत execution चलाते हैं. इसीलिए WB के बाद तुरंत एग्जीक्यूशन स्टार्टेड. WB के बाद तुरंत एग्जीक्यूशन स्टार्टेड बिकॉज ऑपरेंड फेच इज ए पार्ट ऑफ EX. माइंड दिस इज द डिफरेंस. WB के बाद तुरंत EX. WB के बाद तुरंत EX स्टार्ट बिकॉज ऑपरेंड फेच इज ए पार्ट ऑफ EX. इन द रिस्क पाइपलाइन ऑपरेंड फेच इज ए पार्ट ऑफ ID. इसीलिए WB के बाद ID स्टार्टेड in risk pipeline. But this is hypothetical. Hope you understand. ऐसा solve करना. स्नेहा सक्सेस. Operand forwarding concept is good concept. Please don't miss that. Okay. If you have any problem in this explanation, you please watch it again, or you please practice again. Okay, if you are unable to synchronize your speed with my speed, you just watch it again, or you please redo the question, your own knowledge. Concept. We did so many questions in your regular notes. Our regular notes. Okay. Take next one. Take this. Consider a disk drive with the following specification: 32 surfaces, 512 tracks, 512 sectors per track, 1 kilobyte per second, rotational latency 4000 resolution. Disk is operated in a cycle stealing mode, where 4-byte data, so 4-byte word is ready, then it is transferred to main memory. Memory cycle time 50 milliseconds. Okay, the percentage of time CPU blocked in the DMA. What is the percentage of time CPU blocked? Cycle stealing mode, percentage of time CPU blocked equal to y upon x into 100. Y is the transfer time, x is the preparation. Cycle stealing mode. Because of cycle stealing mode, transmission time overlapping with preparation. Pipelining concept is used here. DMA cycle stealing mode. Got y upon x to 100. What is the answer? Y value already given by the student. Y is equal to 50 milliseconds. Transfer time already mentioned in the memory cycle time is already. Now x is a preparation time. Preparation time depends on the disk. What is given? 4000 revolutions per minute. 1 minute के लिए. Then one revolution takes how much time? Revolution के लिए कितना time? Is equal to, okay, 60 upon 4000 seconds. Upon 4000 from 15 millis. So in one rotation, one revolution, in one revolution, in one rotation, okay, one track data covered. That is, one revolution time is required to access one track data. One track में 512 sectors are there. Okay, one sector में 1 KB is there. One track data covered. That is 512 into 1 KB. Data covered. Then how much time is required to access 4-byte word? We want only 4 bytes. 4 bytes के लिए कितना time चाहिए? So what is this? This is the 15 millisecond, one revolution. Then simplify this. This is equal to 15 milliseconds to 4 bytes on 512 KB. So milliseconds, this one cancel, right? 15 into 4 upon 512. So this is equal to how much? 117.18 milliseconds. This is the x value. Preparation time of 4 bytes data is this much. Now substitute those values here. Percentage of time CPU blocked in the DMA operation is equal to, okay, y value 50 upon 117.18 into 100. So 50 upon 117.18 into 100. That is 42.66%. What they are saying, up to 2 decimal places. Then answer is points. Okay, student. This is the DMA related question. Okay. DMA cycle stealing mode. Transfer time already given. Preparation calculated based on the disk. Okay. Disk revolution time calculated. One revolution में one track data covered. But हमको 4 byte data चाहिए. 4 byte data preparation के लिए कितना टाइम required? कितना टाइम? Then y upon x. Students, okay? See the next question. पढ़ो. Consider a program which contains 30% load and store instruction and store instructions. Suppose ideal CPI, an ideal CPI cycle per instruction without any memory stall is 4. Without memory stalls, ideal CPI is 4. Program exhibits 4% on instruction, 12% miss rate on data cache. Okay. Miss penalty 127. Speed up. What is the speed up? Achieved with a perfect cache. Okay, with no data or instruction missing. Okay, so how much performance gain is there with perfect cache over normal cache? Normal cache में compulsory miss is there. Without miss, okay, when you run the program, how much performance gain is present? That we need to calculate. Load and store instruction. Ideal CP. Okay. Then how to solve the question? Please. Now, come to the solution. First, we can take the I cache, instruction cache. Then we take the D cache, data cache. Okay, instruction cache, there is a 100% of the program may, right? 100% of the program, 4% miss. 4% miss, 96% hit to access instruction. Hit के लिए 0 stalls, no penalty. But miss के लिए stall is there. कितना? Penalty कितना? 120 cycle. Penalty is there. Okay. So number of stalls in I cache is equal to कितना? 0.04 into 120. Coming to D cache, data cache. When we have a program, in the program, 30% of instructions are load, store. 30% of instructions are load, store. 70% of instructions are data cache. 30% 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 of instruc load and store. Obviously 70% of instructions are non-load store. Non-load store. Non-load store मतलब no need of the memory reference. No need of डी कैश. इसके लिए डेटा कैश जरूरत ही नहीं है. ओके, लोड स्टोर के लिए डेटा कमिंग फ्रॉम मेमोरी. लोड मेमोरी रीड, स्टोर मेमोरी राइट. लोड स्टोर वांट्स मेमोरी, डेटा फ्रॉम मेमोरी. नॉन लोड स्टोर के लिए मेमोरी इन्वॉल्वमेंट नहीं है, तो नो नीड ऑफ डी कैश. बट ये 30% लोड स्टोर डी कैश एक्सेस किया तो वहां 12% मिस इज देयर. ये 30% में 12% मिस इज देयर. ओके, रिमेनिंग 88% हिट इज देयर. हिट के लिए नो पेनाल्टी, 0 स्टॉल्स. मिस के लिए पेनाल्टी इज देयर. कितना? 120 साइकिल्स पेनाल्टी. Therefore, number of stalls in day cache. Data cache में stalls कितना है? That is 0.3 into 0.12 into 120. These many stalls. This is the stalls calculation. Correct? Now what is the value? Here stalls 0.04 into 120. That is 4.8. This 0.3 into 0.12 into 120. 4 point. Okay. Therefore, execution time equal to execution time of normal cache with miss. Okay. That is ideal CPI plus number of stalls. Okay. In cache into cycle time. Cycle time not given. Therefore, cycle time लेने का जरूरत नहीं है. So 4 plus 4.32. That is 8.32. This is the normal cache execution. Okay. Perfect cache execution time is no stall. In perfect cache, no mispress. Therefore, no stall. So, execution time of perfect cache map equal to ideal CPI only into cycle time. Cycle time is not given. Therefore, 4. So, what they are asking? Speed. S is equal to, okay, 8.32 normal cache execution time divided by perfect cache execution time. 8.32 upon 4. This is 2.08. Student, this is the way to solve the question. This is also some special question. We are thinking that this question is related to cache memory, but this formula is related to pipeline. Pipeline में आपको पता है ideal CPI of pipe plus number of stalls per instruction into cycle time, है ना. वो फॉर्मूला हम ऑलरेडी क्लास में एनालाइज किया. सेम काइंड ऑफ फॉर्मूला यहाँ भी रिक्वायर्ड. क्वेश्चन टर्मिनोलॉजी कंटेन कैश मेमोरी, है ना, बट फॉर्मूला इज रिलेटेड टू पाइपलाइन. होप यू अंडरस्टैंड. Is this clear, students? Okay, then solve this question. Consider two-level memory organization. Consider where level 1 time of level 2 is a main memory, has access to 120. Two-level memory. Level 1 is cache memory. Level 2 is main. Assume hit ratio of a read operation 0.7. System generate 35% rest used for read. Average memory access consider both read and write operation. If cache is designed write through protocol, want the average memory access considering both read and write through protocol. Solve this. What is the answer? Here, two-level memory already given. Okay, level 1 memory, cache memory. Level 2 memory, main memory given. Later, write through protocol given. Write through protocol given. Then TC, access time 20 nanosecond given. TM, access time of main memory 120 nanoseconds given. Then hit ratio of read 0.72 given. Hit ratio of write not given. This is math. When hit ratio of write not given, assume HW is equal to 1. When HW is 1, then use simultaneous access reorganization. Simultaneous access memory organization formula required. HW1 means simultaneous access memory organization required. Okay student, next. यहाँ तक हम ऐसा सोच के आया, cache memory means hierarchical formula, but HW not given, we are assuming as 1, so that's what it is, simultaneous access memory. After that, frequency of write operation 35%, frequency of read operations 65%. Okay, then they are asking the T average. Okay, right. Now read cycle time. Read operation के लिए read cycle time T average subscript R. T average of read equal to HR into TC plus 1 minus HR into TM. Don't say TM plus TC because of it is a simultaneous access memory organization. Simultaneous access memory में no level to level communication. ठीक है? So now 0.72 to 20. plus 1 minus 0.7 into 120. Calculate. $33.6 0.72 into 20. 14 equal to 48. Verify. Next, T average write cycle time. Write cycle time T average of write equal to only TM simultaneous write operation maximum time 120 nanoseconds. Therefore, T average of write through protocol considering read and write is frequency of read into read cycle time plus frequency of write into write cycle time formula. So frequency of read, how much? 0.65 into read cycle time 48 plus frequency of write 0.35 into write cycle time 120. Compute that. 0.65 into 48 plus 0.35 into 120. This is equal to 73.33. So many of you are taking wrong interpretation that as a hierarchical. Okay, TM plus T आप ऐसा सोचते, but this is not hierarchical related question because HW not given. When HW not given, assume HW equal to 1. Now memory organization is simultaneous organization. That's what formulas are changing like this. Formulas. Okay. Yes, yeah, correct. Similar question I given because many students are taking the wrong interpretation here. Okay, similar paper also. Mock. Very good. Then see this question. Consider 6-stage pipeline where the branch and memory instruction not overlap. Branch instructions, memory instructions not overlap. Target address available at the end of 50. Okay. Memory instructions penalty 3 cycles. 3 cycles penalty. Respective stage delays nano 3, 2 nano 3. Program contains 50 memory, 50 branch instructions, 70 AL instructions. Okay, speed up of a pipeline over Students, pipeline given, speed up we want. Here k value is equal to 6. Cycle time is equal to of non-uniform. So max of 5 is the n is equal to 60 plus t plus 70. So equal to 1 8. This is finite. 180 instructions finite. When it is finite, execution time is k plus n minus 1 into t. Know that. When n is infinite, CPA equal to 1. Okay. When n value approaches to infinite, CPA of the pipe is 1. But n is finite, k plus n minus 1 into t. But here what is given? Given is 60 instructions, penalty. Let us calculate. Number of stalls per branch is equal to, okay, branch instructions penalty, 5th stage में target address available -1, 4. So number of stalls per data transfer, okay, that is memory instructions penalty per memory instruction. So now memory instructions penalty already given. Therefore, number of stalls in the program. In the program, how many stalls present? That is, 60 memory instructions into 3 stalls plus 50 branch instructions into 4 stalls plus 70 ALU instructions into 0 stalls. 0 stalls. This is 60 into 3 plus 50 into 4. This become 380. Total 380 stalls present. Therefore, n is equal to 180 plus 380. This is 560. Total instructions are 560. So execution time is 6 plus 560 minus 1 into 5 nanoseconds. Plus 5. 2825 nanoseconds. This is the formula, right? K plus n minus 1 into TP. Non-pipeline execution. Non-pipeline execution. N is already given 180. TL, one task execution time of state delays. Summation 2 plus 3 plus 2 plus 3. Then, so execution time n into TL. N is 180, Tn is 60. So 180 into 16. This is 2880 nanoseconds. Now speed up. S equal to non-pipeline execution time upon pipeline execution. 2880 upon 2825. This is 1.01 up to 2 decimal places or 3 decimal places. 1.019. This is the way to solve the question. Okay, students, when n is given finite, k plus n minus 1 formula use karna. When n is not given infinite, then CPI of the pipe is 1. So that 1 plus number of stalls per instruction into cycle time. So formula, you know that. Okay, students. All right. So now we are closing the session. Thank you all, my dear students, a lot for your valuable support. Right. So actually, in our regular class, I given set of questions in our regular notes. Okay, there cache memory, mapping, replacement, such questions I already explained. Again, same question repeat करने का जरूरत नहीं. That's what I selected some different questions apart from the regular running. Okay, so this session hope helpful to you. Okay, I'm realized that you are in a proper track to decode the question in a proper direction. So maintain the same energy, same confidence. Okay, in the final exam. Okay, student. Thank you so much for your valuable support. God bless you. Take care. All the best.